Okay, I think we've given everybody a chance to join us. Welcome to the Displaying Multivariable Ternary Diagrams in Grapher webinar. My name is Sabrina Pearson, and I'm the Grapher Product Manager. I've been with Golden Software for about 17 years and have been the Grapher Product Manager for most of that time. I'm here today to introduce you to some of the uses of ternary diagrams in Grapher. The topics of discussion today, we'll talk about what a ternary diagram is and how to read it. We'll talk about the ternary data file layout and what's needed and maybe desired. We'll talk about normalization of ternary data. We'll walk through the steps of creating a ternary diagram, and we'll create several scatter plots, class scatter plots, and bubble plots. We'll then edit some basic ternary plot properties, and then we'll finish up by editing the ternary axes. After I discuss each topic, I'll pause for a few minutes to answer any questions. You can send your questions to the webinar host via the questions function at any time. The questions box is on the webinar control panel. Just type in your question and hit send, and it will be sent to the webinar host and forwarded on to me. If your control panel is currently minimized, click the View menu and uncheck Auto Hide the Control Panel to see the chat section. If we're running short on time or I don't get to your question, I'll respond to your question via email after the webinar is complete. This webinar is also being recorded, so after the webinar is finished, a video of it will be available on our website at www.goldensoftware.com. Okay, so let's go ahead and get started. Okay, so what I have here is just a pretty basic ternary diagram. A ternary diagram is a graph that shows three variables in 2 dimensions. By using only 2 dimensions, you don't have to worry about the 3D aspect or confusion over how to read a 3D graph when you're interpreting the data. But in order to show only 3 variables in 2 dimensions, you have to lose something, and so what you lose is true values, and what you get is proportional values. So ternary diagrams always display proportions of the 3 variables that you're graphing. So we'll start here by talking about the different parts of the graph and how to read it. So this graph is the default appearance. And it contains just a single data point right here. So we're going to turn off various parts of the graph and then talk about how you can read that value off the axes. Okay, so I've just kind of copied this same graph multiple times. So this is that same graph, same data point, with only the x-axis visible. So the x-axis is one of the 3 variables. It's displayed on the bottom of the graph. The way you read a ternary graph is everything along this long line is 0% of the variable. As you increase toward the point of the triangle, the values get larger. So this red line, this dark red line, is x equals 0. The next light gray line is x equals 10%. The next one, x equals 20%, and so on. The x-axis grid lines are always inclined to the axis at 60 degrees. When you hit this point here, your data point is entirely x and no y or z. When it's along this line, it's entirely y and z and no x. So if we wanted to read a value off a data point on the graph, what you would do is draw an imaginary line that's parallel to the grid lines, like this. So this line is parallel to the grid lines on either side of it and extends down to the x-axis. You then read the value at the point where it crosses. So in this case, we're somewhere between 50 and 60 on the x-axis, or an x value of about 55. The x grid lines are always tilted to the right. Now we're going to look at the same graph, but with the y-axis highlighted. So the y-axis is the axis on the right side. The 0 line is along the bottom, and it's highlighted in blue here. As you increase up the graph, you go from a y value of 0 up to a y value of 100%. When you hit the peak at the top, you're at y equals 100. When you're at the bottom, you're at y equals 0, and the point is entirely made up of x and z data. Again, to read a data value, you draw an imaginary line that is parallel to the y-axis grid lines, and then come over to the y-axis to read the value. And again, this is between 10 and 20%, or about 15. So we've got an x value of 55, a y value of 15. Because we know the data values have to add up to 100, we can add 55 and 15 to get the z value, or we can actually go ahead and interpret the z value the same way we did the x and the y. So I'm going to go ahead and turn off this y-axis and turn on the graph that shows the z-axis. So the z-axis, grid lines tilt to the left. The z equals 0 line is on the far right side, shown here in the purple line. If the point were to fall on this line, we would have no z value. As you increase toward this point, the z values increase. So if it were on this grid line, z equals 10%, z equals 20%, z equals 30%, and so on. When you hit this corner, you're entirely composed of z, so there's no x or y component to your data value. To read the z value, again, we could add the 55 and 15 and subtract them and get 30, or you could draw that imaginary line back to the z-axis, and as you can see, it hits the z-axis right at z equals 30%. The points will always add up to 100%, so as soon as you know two variables, you also know the third. I'm going to go ahead and turn off that z-axis and turn back on the default graph. Are there any questions so far? Somebody's asking, is it possible to get the ticks aligned parallel to the grid lines? Yes, so we'll talk a little bit about the axes a little bit later, but to answer your question right now, you would go ahead and click on any of the axes to select it. And then in the Property Manager, you would click on the Tick Marks tab, and you would check the Angled Marks option. That then uses the little carrots for the tick marks. Remember that for the x values, you want to be going this direction, for the y this, and for the z that. I just changed them for one axis. You can change them for all three if you like. The easiest way to change them for all three is to actually just select all three axes at the same time and then check the option. Somebody's asking what version of Grapher did ternary graphs first appear. I think it was Grapher 3. I could be mistaken on that. It was either 3 or 4. Are there any other questions about reading or understanding the ternary graph? Somebody else is asking if we can go through just one more example of how to read a data point. So rather than go and edit the data and add a point that way, I'm just going to go ahead and draw a point on the graph. So I'm just using the draw symbol, and I'll just click on the graph, let's say here, because it falls at grid lines, it's easy to read. So to read this data point, I'm going to follow this grid line down. So I've got an x value of 20%. I'm going to follow the horizontal grid lines to the right, have a y value of 60%, and then follow the z-axis grid lines up and a z value of 20%. So that's 20, 60, 20 on the three axes. And just one more example. Let's say put it on the line, since we haven't really shown one of those yet. So this data point, if you follow the parallel line down to the x-axis, you've got an x value of 0. So there's no x value in this data point. If you follow the horizontal grid lines over to the y-axis, you've got a y-axis value of 30 and a z-axis value of 70. So this point would be 0, 30, 70 on the x, y, z variables. Somebody else is asking, is it possible to get rid of one of the carets, leaving just the one parallel to the relevant axis? At this point, no. It does show the full caret just because, you know, the grid lines are relative to both directions, but I can certainly add your request for that to our suggestion list. Are there any other questions? Nope? Okay, so let's go ahead and move on to talking about the data file layout. So now that we know what the ternary diagram is, and you know how to read the data values off of it, let's go ahead and look at a couple data sets that you might use to create a ternary diagram. So to open a data file, you just click File, Open, and I'm going to open this oil, water, gas data file. As you can see, I've got 3 columns of data: oil, water, and free gas. And these are just measurements that were taken in voids, showing the volume percent of each. Because it was only recording these values, the values automatically add up to 100%. But that's actually not necessary. They could be any values as long as the units are the same. So I'm going to go ahead and open a different data file that shows just a different source of data. So File, Open again, and I'm going to open the recorded strain file. So this data set's a little bit different. The ternary data columns are the A, B, and C again. They don't have to be in A, B, and C. They can actually be in any columns that you want. You can change the ternary diagram after it's created to show any columns in your data set. But as you can see here, these 3 columns do not add up to 100%. These are showing volumes of each compound instead of a percentage. If you want, you could normalize the data, or you could plot these unnormalized data points. The key to plotting unnormalized data points is to make sure that they're all in the same units. So these might all be in grams if I'm comparing weight, for instance, or they might be in, you know, molecular weight, or percentage, or some kind of volume, just something that you're comparing apples to apples across all your variables. When you plot the data, Grapher will automatically normalize them. So with the oil, water, gas, you would actually see a data point, for instance, at x equals 90, y equals 5, z equals 5 when you create this graph. With this data file, you would not see a data point at x equals 0.56. Instead, these values are added up and then normalized by Grapher. So you would still see a percentage of each, not the actual data values. As you can also see, this data file also has an extra column. This extra column could be used for the class in a class scatter plot, or it could be used for the bubble size in a bubble plot. You can also use other text variables for classes, and the classes and the bubble plots work pretty much identically to the way they work in 2D graphs. Are there any questions about data or data layout? Somebody's asking, what about replication? So I assume you mean if you have duplicate data points, like if I just have this data point down here. Grapher would actually plot a point for each row in the worksheet. It might not be initially obvious with just a regular scatter plot that you're seeing two data points if they're identical. If 2 points normalized to the same thing, the same issue would happen. So if you have multiple data points and you're showing labels, you may need to move the label. How does normalization work? Awesome question. We're just about to talk about that. Are there any other data questions at this point other than normalization? So how does Grapher handle non-normalized data? So in this case, I'm just going to go ahead and create a ternary diagram real quick. We'll walk through these steps in a little bit more detail. So as you can see in this case, the values 0.56, 1.3, and 1.6 show up in the graph at the normalized location. So you don't actually see the non-normalized data. Okay, so let's talk about normalization. We'll manually walk through the process, again, as long as your units are the same in the columns. So for instance, these are all grams or molecular weight or something like that. You don't need to normalize the data. When you would need to normalize the data is if your three variables are recording three very different options. So you kind of want to make them always the same units, the same relative values. That way, once it does normalize, the normalization actually makes a little bit of sense for your data. Okay, so the way that Grapher does the normalization is it takes the three values and adds them up. So I'm going to make a total value column right here. And I'm going to use the cells data transform command. And in the transform equation, I'm going to type E equals A plus B plus C. And when I click OK, it just adds up all of the values in these three columns and gives me a total value. I can then create a normalized column by dividing the original column by the total value. So if I want C29 norm, again, I can go to the data transform command. And I'm going to say F equals A divided by E. So that's C29 divided by the total. And click OK. And as you can see, these are all less than 1. So that's a percentage of the total. And then I can do the same thing for C28. Data transform. And this is G equals B divided by E, not F. So G equals B divided by F, so C28 divided by the total, and OK. And one more time for C27. Data transform, and H equals C divided by E. And if we were to add up these three columns, they should add up to 1. So if I put a new total column in here, I can go to data transform and add them up. So I equals F plus G plus H. And click OK, all the values are 1. So this process, adding up the totals from each row separately, and then dividing the original data file by the total value, comes up with a proportion, and then that proportion is what's plotted on the graph. So if we were to create our original data file from these columns or these columns, the points on the graph would be the same. Are there any questions about manually normalizing? Somebody's asking, do I have to normalize? No. Thankfully, Grapher does all of this part internally, so as long as your data are in the same units, you don't need to normalize the data. If they're not in the same units, rather than normalizing, what you would need to do is multiply by molecular weight or something like that in order to get normalized data. So they just need to all be in the same units. Once they're all in the same units, Grapher will plot the data exactly the same. Are there any other questions? Nope. Okay. So you can create scatter or ternary diagrams directly from a worksheet or from a plot window, or you can add ternary diagrams to each other so that you have multiple stacked ternary diagrams. So the first thing I'm going to do is walk you through the process of creating a ternary diagram from a worksheet. So we'll just go back to this oil, water, gas data file. To create the ternary diagram, you just highlight the 3 columns and then click the graphs, create ternary, and then choose the type of ternary diagram that you want. The first is a scatter plot, the second is a line scatter plot, the third is just a line plot, and then you have the class scatter and the bubble plot. For this data, I'm just going to go ahead and create a scatter plot. And after clicking the button, you can see the graph is automatically created. As with any other graph, to make any changes, you would just click on the plot in the Object Manager, and then all of the options are available in the Property Manager. So in this case, I've got the X column as oil, the Y column as water, and the Z column as free gas. If I wanted that different, I would just highlight the column in the Property Manager and change them. So now I've got water on the bottom, so this is the 100% water. Free gas on the y-axis, so this point is 100% free gas. And on the z-axis is oil, so the far left point is 100% oil. You can also start with a plot window and select any data file. The data file doesn't have to be opened. So I'm just going to go ahead and click the File, New, Plot to open a new blank plot window. Then to create the graph, on the Graphs tab, click the Create Ternary. And for this example, I'm going to go ahead and choose the class plot. And then you can select your data file and click Open. Same way with the scatter plot, you can change the X, Y, or Z columns. With a class scatter plot, you can also click the Edit button next to Classes and change the class type. So this is currently set to equal number. I can change it to name because this has text columns. And then as you can see, I've got class 1, 2, 3, and 4, and I've got 4 different symbols for them. And when I click OK, the symbols appear on my ternary plot. You can also add a plot to an existing graph. Works much the same way as it does in 2D. So you can just click on any part of the graph. So I'll just click on the ternary class plot. And then on the Graphs tab in the ribbon, instead of clicking the ternary in the Add to Graph section, you would click Plot. So Graphs, Add to Graph, Plot. The Select Plot Type dialog shows only the plot types that can be added to the ternary axis. So I'm just going to go ahead and select ternary plot and click OK. And then I'm just going to go ahead and select that oil, water, gas data file and click Open. And as you can see, the points are added to the ternary plot. So you can really layer your ternary diagram by adding additional values, additional plots. Are there any questions? How can you rename your axes? Great question. Okay, so let's go back to this plot where we know what the axes values are. So the X column is water. So I could click on the X-axis, and then on the Axis tab, in the Title section, I can click the Editor button. And it has X-axis here by default. And I think we said this one is water. So I typed water and click OK. and the text is automatically changed. I can repeat those same steps for the y-axis, which I believe is gas, free gas, and click OK. And the z-axis is oil. That puts the titles on the center. You can also move the titles to the corners. There's two ways to do that. You can either move it with the X and Y offset. So with the X-axis, I'll go ahead and show this method. So you can increase the X offset value and the text moves to the right. And then you can increase the Y offset value and the text moves up. So that would give that label in the corner. So you could do that for each axis. The other thing you can do is use the Move Labels command. So on the Graphs tab in the Plot section, click the Move Labels, and then click on the title, and you can drag it up to where you want it to be. And hit Escape when you're finished. And then if you want the text to be at the same angle, you would just rotate it 60 degrees. I'm just going to use that same process for the oil label. Oops. For the z-axis -60. So then you have the corners labeled instead of the axis. Where did the classes come? Okay, so when I created this class plot, I used a data file that we actually hadn't looked at yet. So I'll just go ahead and open that plot or that data set real quick. So the X, Y, and Z values are listed in the first three columns, and the class is listed in the fourth column. And these are just class 1, 2, 3, and 4. This is just a sample data file, so it doesn't have a whole lot of information about the class, but the class could be depth that the value is taken at. It could be a well ID. It could be genesis of the sample. It could be sample name. It could be the sampler's name. So you can really have that class be whatever it is that you need to highlight. So if you're looking for a particular additional fourth variable that you need to know about, that's where you would use that class. Are there any other questions? Okay, so somebody's asking about bubble plots. So very, very similar process with the bubble plot as with the class plot. I'm just going to go ahead and create a new plot window and then click the Graphs, Create, Ternary, and choose Bubble Plot this time. And I'm going to use that recorded Sterains data file that we looked at before and click Open. And what I see here is the points are plotted in the XYZ location. So that's the C29, C28, and C27. And then the size of the symbol is actually coming from that fourth column, that depth column. So what that kind of shows us is the larger the bubble, the bigger the depth. So that's just another way to show that fourth variable on your ternary diagram. The bubble sizes are changeable, so when the bubble plot is selected on the Plot tab, you can change the minimum radius and maximum radius to make the bubbles either smaller or larger. You can also change the symbols, etc., all in the Property Manager. Are there any other questions? Somebody's asking, can you use a template that identifies various regions? I do have an example using the Sterain data, so it's not a true template in that it's just a GRF file, but I'll go ahead and open that. So File, Open, and then you would open your GRF or GRT file. This plot actually shows two ternary diagrams already created, and rather than these being scatter plots, these are line plots. So in order to get the polygon to display, the symbol frequency is set to 0, and the line style for the plot is set to solid. and then the points in the data file are just in order going around the area. So the reason for that is, if I'm comparing data points and I want to know is the genesis of the data marine versus non-marine shale, I can compare these data values on this graph by adding a plot to this graph. So once you have the graph open, you can go to the Graphs, Add to Graph Plot, select the type of plot that you want, and click OK, and then select the data file and click Open. As you can see, most of the data points fall in either marine or non-marine, and that's just because this is a sample data file, so it's all perfect, right? And then there's a couple data points that are falling outside those areas. But this same process would work with any ternary diagram. Somebody else is asking, how do you make the axis 0 to 100 instead of 0 to 1? Great question. So the 0 to 1 is showing proportions. If you want to show percents instead, you can click on any axis to select it. Changing one axis in this regard changes all axes. In the Property Manager, click on the Axis tab, and then in the Limits section, check the box next to 0 to 100 scale. And as you can see, all three axes change to the 0 to 100. Somebody's asking, can you tell us something about how to interpret the graph? If some data came from gas, water, oil overlap, then what does it mean? Sadly, I don't, my geology skills are pretty rusty at this point. Basically, all this is telling me is that the data points collected in this range are coming from a marine shale. The data points coming from this range are coming from a non-marine shale. There are lots of resources available on the internet as to how to interpret the various options and what it means. With the oil, water, gas, obviously if you're looking for oil, you probably want to be drilling in the areas that have the more oil values, less water, just so that your oil-water contact is higher. It really just depends on, what it is that you're looking for. But there are lots and lots of books that talk about how to actually, make anything useful out of the data points. Somebody else is asking if there's a way to reverse the axes. Not a simple way, but there is a way. I'll talk about that at the end of the webinar, if that's okay. Okay, so let's talk about editing basic ternary plot properties. So with this graph up, it's a pretty simple graph, just showing little black symbols with really nothing else, even labels. Just like with any other plot in Grapher, to make any changes, you click on the plot in the Object Manager, and then all the properties are available in the Property Manager. So on the Plot tab, you can change the XYZ columns and the worksheet rows. For the bubble plot or the class plot, you could also change the bubble size or the class sizes. If you want to change that little black circle, you would click on the Symbol tab. You can change the symbol to any option that's available. By default, we are using the GSI default symbols. If those symbols aren't showing you what you want, you can change the symbol set to any true type symbol set on your computer. So if you have a specialty oil and gas symbol set, for instance, you could use that, or you could use like the GSI oil and gas. You can actually get the symbols from a symbol column. I don't have a good example of that right now, but basically the symbol column would have the number of the symbol in it. So if you, for instance, really wanted just the empty open symbol, you would set your symbol set to this GSI symbols and then use symbol number 0 in your symbol column, and then you would just change the symbol column to the symbol column in the worksheet. I'm going to go ahead and change that back to default symbols. To change the size, you just highlight the value and type a new size. You can make it small or large or somewhere in between. To change the color of the symbol, filled symbols like this diamond have both a fill and a line section. So you can click the plus next to fill and then change the interior color. And then as you can see, the symbols are interior orange with an exterior black line. Let's make that size a little bit larger. And then you also can change that black line on the outside. So we could make it orange to match the symbol, or we could make it something contrasting like blue and then change the line width as well. And that's just the line width of the exterior of the symbol. You can also use a symbol table, which just does a random symbol. Probably not as useful as the symbol column, which is a specific symbol from the worksheet. You can also connect the symbols with a solid line or with a line. So you would do that by clicking on the Line tab and next to Style, change Invisible to Solid. The points are connected in the order that they're located in the worksheet. So as you can see, these points really aren't in the worksheet in any uniform kind of order. But if your points are, and it's meaningful for you, you can connect the points with the line. And then finally, probably the option that's most different for ternary diagrams is the labels. So you can click on the Labels tab, and then the first option you would want to check is the Display Labels. I'm just going to zoom in on a couple points here. What you can see is the labels initially show 3 values. These are the normalized X, Y, and Z values from the worksheet. On that Labels tab in the Property Manager, you can check or uncheck the Include X value, Include Y value, and Include Z value options. So that would just remove that particular value. So if I don't want to show the Y value, I uncheck that. And if I don't want to show the Z value, I can uncheck that. This can highlight the percentage of whatever option that is most important to you. So if this is an oil, water, gas kind of graph and you're looking for oil, you may want to highlight the oil percentage. You can also change the label order when all of them or parts of them are shown. So by default it's XYZ, but you can also change it to YXZ, ZYX, ZXY, pretty much any of the options. If you don't want to use the X, Y, and Z values, instead you want to use some other option, you can check the option next to Use Worksheet Labels, and then the values from the worksheet are shown. So in this particular data file, you remember this was the very simple, only 3 columns data file. There aren't a whole lot of other options here, but you could have an ID, a well information, you could have other information, other variables that you may want to display on this as well. So this column can be any column in the worksheet. You can also change the font, format, etc. I think normally when I've seen it, when people are showing X, Y, and Z as their labels, they want to have them in parentheses. You can add the parentheses by clicking the plus next to Format, and then scrolling down to the prefix and suffix. So if you click the Editor button next to prefix, you can include the left parenthesis. And if you click the Editor button next to suffix, you can include the right parenthesis. And then it just kind of cleans up your labels a little bit. Just like with the axis titles, you can also move labels around. So this section over here and this section right here are pretty messy. So you can actually click the Graphs, Plot, Move Labels command, and then click and drag the labels to a place where it makes more sense for you. When you're finished moving the labels, you can just hit Escape and the labels stay in their new positions. Are there any questions? Is there a quick way to identify the point on the graph to the original data file? If you have like a whole ID or a sample ID, you could show that using that worksheet label. So you check the Use Worksheet Labels option and then set the column to your label ID. How do you add a legend to the bubble plot? Oh. Let me see, where's my bubble plot? So all legends are added in pretty much the same way. So you would click up somewhere on the graph to select it and then click the graphs add to graph legend command. In Grapher at this point, the bubbles only show a single symbol. If you want multiple symbols, you would actually have to create that a little bit manually. I will definitely add your request for that to our suggestion list. What if I would like to separate numbers with commas instead of stops? Okay, so I assume that you're talking on the labels. So at this point, the label is always a comma. And I think that's true regardless of what your Windows locale is. If you want them to be spaces or some other thing, I would say you probably want to add a column to your worksheet. So I'm just going to click on the oil, water, gas data file and add a label column. And then I can put in this label column whatever I want. So I can put 95.5, 87.13, and I could do that for the whole graph. And then back on the plot, click on the Ternary plot on the Labels tab, check the Use Worksheet Labels. And then I can set it to that label column. And as you can see, this has spaces because that was what was in the worksheet. But you could actually change this to dashes or anything else. That's all just by what's in that label column in the worksheet. Are there any other questions about editing the plot? Okay, so then the final section is talking about the axes. So we've kind of talked a little bit about the axes as we've been editing other options. Normally with ternary diagrams, what you want for one axis, you want for all axes. So for instance, if I want the tick marks to be at 10% instead of at 20%, I would actually probably want that on all of my axes. So you can click on the first axis to select it, hold down the Control key, and click on each additional axis. And then all of the options in the Property Manager will pertain to all three axes. So on the tick marks tab, I could change that to 0.1, and now I have a major tick mark at each 10% instead of 20. I could change it to 0.4, basically whatever you want. I could also turn off the display of minor tick marks or control the grid lines. So for the grid lines, usually what you're going to want is uniform grid lines just so that the grid lines don't become overpowering. But some people actually want to use grid lines as color-based. That way they can see a little bit more variation on their graph. So if you're wanting to do that, you would click on the Grid Lines tab for your axis, and then click the plus sign next to Major Line Properties, and you could change the major line to, say, for instance, red, and then repeat the same process for the minor line properties. And then I'm just changing these to have some slight opacity as well. That way they're not, real bright red. You could do this however you like. You could then repeat the same process for the y-axis, choosing a different color. And that kind of would color highlight your graph a little bit. Another option that's unique to ternary diagrams, we talked about the tick marks going angled. That's on the tick marks tab, and just checking the angled mark section. As you can see, clicking on just the angled marks for one axis at a time only changes that axis. The other option would be the limits. So with most axes in Grapher, you would click on the Axis tab, and then in the Limit section you can just highlight the values and change them to whatever you want. With a ternary diagram, the process is a little bit different. So the axis always goes either from 0 to 1 or from 0 to 100, and all of the axes change at once. Or you can highlight a section of the graph. So if I am most interested in these data points right here, I can click on an axis to select it, and then click this Select button next to Limits. see my cursor changes to a triangle. I can then highlight on the graph, so I'm clicking the left mouse button and dragging the mouse to show an area of selection. The rectangle inside that triangle is where I actually clicked. So I clicked in the top left and the bottom right. The triangle shows the limits of the graph, what those limits will be once I release the mouse button. So when I release the mouse button, the limits on each of the three axes change, so only that section was highlighted. I'm just going to undo that change, and then I'm going to make a copy of this graph and paste it. That way you can see them side by side. So again, you click on an axis to select it, click the Select button next to Limits, and then drag the rectangle to show the triangle and the area of interest. So now instead of showing all of these data points, you're showing just a zoomed in portion. You would want to use this instead of the magnifier option or the draw inset zoom, because this shows you the axes limits as well as the data points inside those limits. Are there any other questions? Okay, it doesn't look like it. Okay, so that concludes today's webinar. If you have any questions, we'll hang around for a little while to assist. If you have any questions after the webinar is over, you can call our technical support line at 303-279-1021. You can email us anytime at graphicersupport@goldensoftware.com. And from 9 to 4 during the weekday, we also have live chat available. Ternary diagrams are one of those specialties that's a little bit hard to just jump into the middle of a conversation on. So if you have some questions about ternary diagrams specifically, it's probably best to send it via email and send your data file so that we can take a look at it as well. I did tell you that I would mention the reversing axis. Thanks for the reminder. There is a knowledge base on our website. It's knowledge base number 1870 that walks through the process of how to switch the axes to go the opposite direction. Basically, the steps that you would use are you change the data columns first. After the data columns are changed, you have to create worksheet labels for each axis. And all the steps are outlined here. And there's also an example ternary graph. Once you have the ternary graph, the labels updated, it creates a graph that goes in the opposite direction. Are there any other questions? All right, everybody, have a great day.